बॉटनी अटेंड करना है पर ये अटेंड नहीं कर तीन बच्चों में रिवीजन कराने के साथ में से 3 बच्चे हैं
है ना। और इन लोगों को इतने कम इसलिए क्योंकि आप तब हायर कर रहे हो जब आपको
Am I audible, everyone?
Yes.
Okay. So today we're going to discuss about the most important topic in the circulatory system, that is the cardiac cycle. Okay. Cardiac cycle. If we are talking about the term cardiac, means we are talking about the word heart. Okay. Okay. So let's first understand about the why we are calling it the cardiac cycle. Okay, we have to understand about its definition also, or we have to be clear about the meaning of the cardiac cycle. Okay, so cardiac cycle is denoting the cardiac events that occurs from beginning of one heartbeat to beginning of next heartbeat, or in the simple words we can say all the events which are occurring between the one heartbeat and the next heartbeat, or the all the events which are occurring between the two heartbeats are called as the cardiac cycle. Okay, so you can also write it as serial wise, or we can say in sequence, one by one events are occurring between the two heartbeats. Okay, so we can write it as the serial wise or sequential changes takes place in heart. Okay, so that is what we are defining as the cardiac cycle. Okay, let's move further. So before starting about it, there are some of the events. In the simple word, we called it as the contraction and relaxation. Okay, but when we are talking about the cardiac cycle, then contraction term will be analogically used as the systole. Okay, and for relaxation we will use the term diastole. Okay, so whenever we will going to talk about the chambers of the heart, okay, atrium or the ventricles, so systole will also you will going to talk about in the two ways, means the atrial systole or the ventricular systole, atrial diastole or the ventricular diastole. Okay, so these are the terms you will going to use in this complete cardiac cycle. Before moving further, we will going to talk about the, if we are talking about the cycle, so we will also going to talk about the time of the cycle, that in how much time the particular cardiac cycle will going to end, or what is the duration of that cardiac cycle. So we will going to talk about the time of cardiac cycle. Okay, the time of cardiac cycle is said to be reverse ratio of reverse ratio of heartbeat per minute. Okay, when you will going to reverse the ratio of heartbeat per minute. Okay, we know there is the 72 average heartbeats per minute. So when we will going to reverse the ratio, that is the 60 seconds upon 72 beats. Okay, so that will come around zero point 0.8 second. Okay, so this is the duration. This zero point 0.8 second is the duration of the cardiac cycle. Okay, now one by one we will going to talk about the card contraction relaxation means in the atrium and in the ventricle. So first we will going to discuss about the how much time the atrial systole or the atrial diastole, ventricle systole or the ventricle diastole will going to take place. So we will going to write it like as, we will going to write here as the atria, ventricle, okay, and other component is the contraction and relaxation. Okay, so when we're going to talk about the atrial systole means the atrial contraction, atrial systole, so that is around zero point 0.1 second, 0.1 second. Okay, atrial systole is of 0.1 second, but the rest, if we're going to talk about total cardiac cycle is of zero point 0.8 second. So in 0 0.8 second, if 0.1 second is atrial systole, then complete 0.7 second is of atrial diastole. 0.7 second is of atrial diastole. And we will going to talk about the ventricular systole. So ventricular systole is of around 0.3 second. Okay. Then ventricular diastole, we will going to minus it from the 0.8 second. Then the ventricular diastole is of around 0.5 second. Okay, so these are the different timings or the duration of the atrial systole, atrial diastole, ventricular systole, and ventricular diastole. Okay, you have to remember them. You can remember them, or you can understand the concept that the complete time of the cardiac cycle is 0 0.8 second, and of one you can remember. If you remember the duration of atrial systole, then you can know the atrial diastole timing. If you know ventricular systole, you can know ventricular diastole timing. Okay, so this is all about the duration of the cardiac cycle. Now we're going to understand about the cardiac cycle by the diagrams. Okay, okay, so we're going to divide it. So this is of atria. Okay, we have made this cycle of 1 minute. This is a cycle of atria. Same with the division, we will going to make another cycle. And this cycle is of the ventricle. Okay, now You will going to denote them with the timings. 0.1 second, zero point 0.2, zero point 0.3, 0.4, 6. Okay, 0.8 second. Then again in the ventricle also. Okay, now we will going to, as we know in the atria there is the timing of atrial systole. We will going to shade that part. Okay, we will going to shade that part which is of the systole, means the contraction. So in the atrial contraction is of only 0.1 second. Okay, so the starting 0.1 second, is of atrial systole. Then complete unshaded part is of the atrial diastole. And in the ventricle, as we know that 0.1 second, static 0.1 second of the cardiac cycle is the atrial systole. So simple, in the common sense we can know that from 0.1 or for the 0.1 second there is no systole in the ventricle because atrias are at contraction. So the ventricular systole will going to start from the 0.2 seconds. Okay, and we know that ventricular systole is of 0.3 second. So it will going to come from here to here. Anyone having confusion? Anvit, Sinchana, any confusion in this?
No, sir.
Okay. Now one more thing, why we are saying that the initiated atrial systole of the cardiac cycle 0.1 second, first the atria will go in the systole, then from 0.2 second ventricles are going in the systole. So what is the reason behind this 1 by 10 second delay? Both of you have any answer? Sinchana?
Blood will flow from atria to ventricle. So that's why.
uh, Again?
Blood will flow from atria to ventricle.
What flow, beta?
Blood.
No. As we in the previous class only we have studied about the conduction. Okay, we are talking about the contraction and relaxation. Means contraction relaxation is the working of muscles of heart. Okay, blood is not the factor here. What is the factor? When we are studying about the conduction, we have talked about the SA node, AV node, bundle of phase, Purkinje fibers. So we know the SA node is the pacemaker. Means SA node will going to generate or start the heartbeat. Okay, so there is the delay of 1 by 10 second in the atrial systole and the ventricle systole, just because when the action potential initiated or started from the SA node, it will going to be first spread in the atria. Okay, and it will be delayed in reaching to the ventricles because it have to travel more from SA node to internodal pathway, then AV node, then bundle of phase, then Purkinje fibers. Then only ventricular systole will going to take place. So due to this special conducting system present in the heart muscles, okay, SA node, AV node, there is the delay of 1 by 10 second between the atrial systole and the ventricular systole. Is that clear, Sinchana and with?
Yes, sir.
Okay,
Yes, sir.
wait a minute. Rajul sir, कोई न्यूज स्टैंड है क्या?
नहीं सर, ये आउट है।
पहले के ही अपने. Okay, so this is what we have seen in the cycles. So by that you can clearly see that there is the delay of 1 by 10 second. Okay, so you can write here also. You can write in the star mark that due to a special conducting system of heart consists of heart, there is delay of 1 by 10 seconds between atrial systole and ventricular systole. Okay, so now we will move further. Now we are going to join these both the circles. Both the circle means the cycle of atria and cycle of ventricle. We will going to join them. Okay, let's join. How will they look like? Why this we will going to understand better. Okay. Okay, so please remember one thing. This outer circle is of the atria. Okay, this outer circle is belong to atria, and this inner circle belongs to ventricle. Okay, we have merged both the cycles of the atria and ventricle, and now we're going to talk about them. Okay, so as we know, in the atria there is the systole of 0.1 second. So starting 0.1 second will be given to the atrial systole. Okay, and we know in the ventricle systole or ventricular systole, it starts from the 0.2 second up to the 0.4 second, means it belongs to the 0.3 second total. So it will start from 0.2 second. Okay, we have not written the names. 1 minute. First we will go do the timing also. 0.1, 0.2. Okay, so we have done the timing also. So we have talked about the atrial systole, ventricular systole, atrial diastole, and the ventricle diastole. If we have noticed one thing, that we have got the half of the circle when we have merged both the circles of the atria and the ventricle, we have got half of the circle is empty, means no systole is present there. So this is the area of the diastole. This half area is completely belong to the diastole when the both atria and the ventricles are in the relaxed state, means not not a single contraction is present in the atria, not a single present in the ventricle. So this area is called as the joint diastole, or this duration is called as the joint diastole. And if you will ask the duration of joint diastole, so you can notice from here only, from this circle, that joint diastole starts from the 0.5 second and at its end to the 0.8 second, means total joint diastole is of the 0.4 second. If you will ask then what is joint diastole, then this is the period during which entire heart, means the atria and the ventricle both, entire heart is in diastole. Is that clear, Sinchana Anvit?
Yes, sir.
Okay.
Yes.
Now, one by one, we are going to start about the cycle from the first step to the last. Okay, let's start. Now you have to keep more focus. Okay. First of all, you're going to start with the ventricular systole. Okay. First, we're going to talk about the ventricular systole. Ventricular systole. In the ventricular systole, you will going to get the two main steps. First is called as the isometric contraction. Isometric contraction. Okay. And another is called as the period of ejection. Period of ejection. Okay. So in the ventricular systole, we are going to talk about them. Isometric contraction and the period of ejection. So let's talk about the isometric contraction first. Okay, this is the heart. Okay, so till now what we can see that from the atrias, blood are coming to the atrium and then they are moving to the ventricle. Okay, so means the ventricle are filling. Okay, so ventricles are filled with the blood. And as we all know, if there is the filling of anything inside any structure, then there is the increase in the pressure. Okay, so blood is filling inside the ventricle, so there is the increase in the pressure inside the ventricles. So due to the increase in the pressure, what will going to happen? The blood will try to escape. Okay, first of all, blood will try to escape back to the atrium. Okay, but as we know, there is the presence of walls. There is the presence of walls. So what will going to happen? There is the closure of walls due to backflow of the blood into the atria. Means blood is trying to release the pressure. Means ventricles are trying to release the pressure. So blood try to move into the atrium back. But due to the presence of walls, these walls leads to closure. Okay. So walls are closed. Can Anvit or Sanchana, can you name these valves which I have closed?
Tricuspid and bicuspid one.
Very good. Bicuspid and tricuspid valve. These are present between the atria and the ventricle. Okay. So what is the process taking place in the isometric contraction? So in the isometric contraction, walls of ventricles start contracting. Start contracting. Why they are start contracting? As we know, blood is flowing inside. Okay, and pressure is now increasing. And finally, from the SA node, that action potential have reached to the Purkinje fibers, means to the ventricles. So now walls of the ventricles start contracting, and due to the contraction, more pressure is increased. So it increases pressure inside ventricles. Okay, pressure is now increased inside the ventricles, and due to there is the closure of cuspid walls, means both the cuspid, tricuspid and bicuspid. Okay, closure of cuspid walls. So due to the closure of the cuspid walls, the very important thing that will going to happen, that we talk about very oftenly, that we know that heart make the sound lub and dub. Okay, so due to the closure of cuspid wall, there is the occurrence of, or it going to be produced it produces S1, means the first heart sound. S1 heart sound, and that S1 heart sound is called as lub. Okay, so the first heart sound will going to be heard due to the closure of the cuspid walls. Okay, so this is about the isometric contraction. Now we're going to talk about the period of ejection. Means this term that is the period of ejection is saying all thing by its own. Okay, means something will going to eject, and we know from the heart blood only will going to eject. So let's make the heart again. So we are only in the stage where there is the closure of cuspid wall. So means if the cuspid walls are closed, now atria can fill again. Okay, so there is the, so we'll make like this. So there is the closure of the cuspid walls. Okay, so closure walls, closure. So blood is filling now in the atrias also. Okay, blood is filling here. And we know blood is also present here also. So you can understand if you will compare this diagram with the diagram of isometric contraction, you can notice that I am drawing a less blood in the ventricles. Why so? Because due to increase in the pressure, due to the contraction of walls, we know that there is the closure of tricuspid and bicuspid wall, but pressure is increasing continuously. So for releasing the pressure, there is the opening of other two walls, and that are the pulmonary semilunar valve and the aortic semilunar valve. Okay, so blood will now going to flow in the aorta, and from here into the heart, that is into the pulmonary artery. Okay, so what happens in the period of ejection? We're going to write that during increase in pressure of ventricles, there is the opening of semilunar walls. Okay, both the semilunar walls, means the pulmonary semilunar and the aortic semilunar. Okay, so opening of the semilunar will lead to the flow of blood. Blood will rapidly enters into pulmonary artery and aorta. Okay, so this is about the period of ejection. Means first the isometric contraction. Isometric means the homologous in the complete wall of the ventricle. There will going to contraction will going to take place. Not we can say that in the some part or other part of the ventricle. In the complete ventricles means the isometric. Okay, same. And then the period of ejection, that blood now is in the pulmonary artery and the aorta, and still what is happening, atrias are filling. So now we are moving to the next stage of the cardiac cycle, and that is called as the ventricular diastole. We have already talked about the ventricular systole. Now we are going to talk about the ventricular diastole. Ventricular diastole. Okay, so under the ventricular diastole, there comes again two steps. First comes as the isometric relaxation. Okay, we have talked about the isometric contraction. Okay, because we are talking about the systole, but here we are talking about the diastoles. That is what the reason we are talking about the isometric relaxation. Okay, then other we're going to talk about the next stage, that is called as rapid inflow. Okay, this is the next stage of the ventricular diastole. Now we're going to see them. Okay, so in the isometric contraction, what will going to happen? We know that same stage is continued, that there is the closure. Okay, bicuspid and tricuspid walls both are closed, and blood is filled inside the atria. But at the same time, we know that in the previous stage of the period of ejection, means in the stage of the ejection, blood is ejecting out into the pulmonary artery and the aorta, means slowly the pressure inside the ventricle will going to decrease. Okay, and when the pressure inside the ventricle will going to decrease and increase in the pulmonary artery and aorta, because blood is flowing in the pulmonary artery and aorta, so pressure is increasing there but decreasing in ventricle. So again blood will try to backflow inside the ventricles. So, for preventing the backflow of the blood inside the ventricles, we know there is the presence of the semilunar walls, pulmonary semilunar and the aortic semilunar. So, as the pressure will going to decrease and blood will try to flow inside the ventricles, so the closure of semilunar walls will going to take place. So this is the isometric relaxation, means completely ventricles are going into a relaxing stage, diastole stage. Okay, so this is happening just because the amount of blood inside the ventricles has now decreased, so pressure also decreased. Okay, so that is what a reason for preventing the backflow. There is the closure of semilunar and the aortic walls. Okay, they are also closed now. So what has happened? We will going to write that also. So in the isometric relaxation, what has happened? Walls of ventricles, not walls. We are talking about the walls. Walls of ventricles start relaxing. Why they start relaxing? Because now blood has decreased inside the ventricles. Most of the blood has flowed into the pulmonary artery and aorta. So when walls of the ventricles start relaxing, due to that, there is the decrease pressure inside ventricles, and due to decrease in the pressure inside ventricles, for preventing the backflow of the blood, there is the closure of semilunar walls. Semilunar walls. And as we have talked, when there is the closure, 1 minute, when there is the closure of the cuspid wall, okay, when there is the closure of the cuspid wall, there is the production of S1 heart sound, that is lub. So the same, when there will be the closure of the semilunar wall in the isometric relaxation stage, it will also going to produce another heart sound. It will going to produce, that is the second heart sound. S1 is by the closure of cuspid wall and S2 by the closure of semilunar walls. You have to remember that. Okay, so the S2 heart sound will going to produce, and that is dup. D-U-P, dup. So first is lub, second is dub. Lub and dub. Okay, so this is all about the isometric relaxation stage. Now we will going to talk about the rapid inflow, means something rapidly coming inside. Okay, and we know what will going to come, blood will come inside, and atrias are already filled. What is empty? Now ventricles are in the empty stage, means less blood is present in the ventricles. So obviously we're going to talk about that the blood will rapidly flow in the ventricles. So this is the rapid flow, rapid inflow stage, means the atrias are completely filled with the blood. You have to notice one thing, that we are talking about this stage, that is the rapid inflow. Till now we have not said that atrias are going into a contraction. No, before the contraction of the atria, the blood which is present in the atria, most of the blood, okay, most of the blood which is present in the atria will going to rapidly inflow inside the ventricles. Okay, this is the something different in the heart. After the complete flow of blood inside the ventricles, there will be the systole of the atria. See it. We will going to discuss it about. Then we will completely from the starting to the end. We will going to discuss it again. Okay. So there is the less blood in the ventricles and more blood in the atria. Now closure of the seminal walls have already taken place. As to heart sound, we have heard that is the dub. Now what will going to happen, as we know that pressure is increasing inside the atria because atria is completely filled with the blood. So due to increased pressure, there will be the opening of the cuspid walls, that is the bicuspid and the tricuspid walls. Okay. So in the rapid inflow, what will going to happen, due to relaxation in ventricles, due to relaxation in ventricles, pressure inside ventricles or pressure inside them falls further. Okay, it will going to rapidly fall. The pressure will going to rapidly fall, and due to fall in the pressure, there is the more pressure. We know the rule of the pressure or rule of the flow or rule of the diffusion. That is the anything will going to flow from the high pressure to the low pressure or from the higher concentration to the lower concentration. If there is the fall in the pressure inside the ventricles, means there will be flow from the atria to ventricle, because inside the atria there is the high pressure, more blood is present there. So pressure has decreased and there is the opening of cuspid walls. And if the cuspid walls have opened, means the passage between the atria and the ventricle is now open. So blood flows rapidly from atria to ventricle. Okay. And due to the rapid flow or the gush flow, there is the formation or production of the sound. Okay. We can understand by the daily use, if there is the one empty bucket. Okay. And rapidly, if you will put a mug of water inside that bucket, empty bucket, you will going to hear the sound of the rapid inflow of that water. Same way, when the rapid inflow of the blood will going to take place from the atria to the ventricle, there is also production of sound, and that is the third heart sound. Okay. So it will going to produce S3, third heart sound. But clinically, if we will going to talk, then the S1 and the S2, means the first heart sound, will going to be heard more better than the third heart sound. Okay. Because normally if we are a clinician, so we try to hear the S1 and S2 more properly, because S3 sounds are not so prominent. Okay. So okay, so we will move further, and now we're going to talk about the another stages. So we have talked about the ventricular systole, we have talked about ventricle diastole. Now we are going into a diastasis stage. Okay. So we have to understand what is this diastasis. Stage of diastasis, or other name which you are only familiar with, that is the joint diastole. Okay, diastasis, or also called as joint diastole. We know this is of the duration of 0.4 second. Okay, so what will going to happen here? The two main things that will going to happen in the joint diastole, that the atrioventricular walls, means the cuspid walls, open, and semilunar walls are closed. This is the condition which will going to be present during the joint diastole. Okay. So we will going to draw that also. Okay. So blood is now filling, rapidly inflowing inside the ventricles, and blood is decreasing slowly inside the atria. Okay, blood is coming from the three openings to atria, we know, and moving towards the ventricles. In this stage, in this particular stage, the complete heart is in the diastole stage. Okay, nor the atria nor the ventricle are in the systole or the contracting stage. So this complete stage is present for the 0.4 second and called as the joint diastole. Okay, so what is happening in the joint diastole, we are going to write it, that blood receives in ventricles, blood receives in ventricle at the same rate at which atria receives blood from vena cava and coronary sinus. As we have already discussed about this, that there are the two opening inside the right atrium, oh sorry, in the right and left atrium, that is the right atrium, that is the vena cava, superior vena cava, inferior vena cava, and the coronary sinus. Okay, this will going into atria. So the blood from the rate which is coming from the vena cavas and coronary sinus into the atria, at the same rate they are reaching to the ventricles. Means complete heart is in the diastole. All the blood which is coming to the atria is flowing directly into the ventricles. Okay, no systole is present there, or systole of the atria is not responsible for draining the blood from the atria to ventricles. Okay, directly it is going to the ventricle. This is the joint diastole stage. Okay, so at this stage, all four chambers are in relaxed condition, and experiencing equal pressure. Okay, so this is all about the joint diastole. So we have completed about the ventricular systole, diastole, and the joint diastole. Now we're going to talk about the next, that is called as the atrial systole. Okay, so we're going to talk about the atrial systole. According to me, I think so you all have remembered that there is the presence of some of the muscles inside the atria. Sanchana, Anvit, do you remember the name of those muscles? Sanchana, am I audible?
Yes, sir.
What is the name of the muscles which are present in the walls of atria? You are not audible, Sanchana.
Musculi pectini.
Musculi pectineo. Okay, so we have already discussed about those muscles. Those are the comb-like muscles present like this inside the walls of atria. Transverse muscle. Okay, so these are the muscles which is present inside the atria. So when the systole is going to take place of the atria, as I've already told you, without the systole of the atria, there is the complete flow of blood from the atria to directly into the ventricles. But when the atrial systole will going to take place, so the blood which is filled or remain inside the muscles, these calm muscles of the atria, that will going to flow in the ventricle. Means the all remaining blood into the atria will going to reach to the ventricle due to this atrial systole. But the majority blood had already reached to the ventricles in the rapid inflow stage. Okay. So this is the functioning. Okay. So what is happening due to contraction or systole? Contraction of atria. Due to contraction of atria, remaining blood in atria comes into ventricles that we have already talked about. Comes into ventricles. Okay. And we know that we have already talked about this, that in the empty, something empty bucket, we are pouring the water, mug of water, so it will going to produce the sound. But if we will going to discuss again one thing, that there is the bucket which is half filled. Okay, half filled, that almost yes, we can say half filled. And again, if we will going to pour the mug of water from upside, okay, by a pressure, means we are saying na systole is taking place, contraction is taking place, so the blood will going to drain or pour inside the ventricles by a pressure. So we can say that again the some sound will going to be produced due to this flow of the blood. So it will going to produce S4 hertz sound. S4 hertz sound. Okay, you have to remember these things. So there are total 4 hertz sound: S1, S2, S3, and S4. In the next class, we'll going to discuss about the hertz sound. But in this class, just we have already discussed that why the S1, S2, S3, and S4 are produced. What is the source of this production of sounds? Okay. Separately, we're going to talk about these sounds again in detail. Okay, so this is about the atrial systole. Now we are moving and we will going to talk about the atrial diastole. Okay, so if we talk about the atrial diastole, means the atrias are again coming into a relaxed state. Means atrias are relaxed now. So if atria is again going in the relaxed stage, means the filling of blood will going to be continue again. Filling of blood continue again, and now ventricles are almost completely filled. Almost completely filled means again the situation is formed that the ventricles are completely filled. Pressure there is the very more pressure inside the ventricles, and now the ventricle systole will going to come place after this. Okay, means situation is built now. Complete situation is building. So what is happening here? You're going to write that also, that atria start relaxing. Okay, and due to that atria start receiving blood from vena cavas and coronary sinus. Okay, so this is all about the different stages of the cardiac cycle. If we will going to continue again talk about this cardiac cycle, so we will going to, as we have complete the atrial diastole. So in the atrial diastole, what we can see, that heart ventricles are completely filled. Again the atria start filling, and so this is the stage of the situation that the ventricular contraction will going to take place again. So we will going to ventricular systole again. Okay, so again the ventricular systole will going to take place. As the ventricular systole isometric contraction will going to take place, due to the contraction, again the pressure will going to increase. Closure of the atrioventricular valves and the opening of semilunar valves will going to take place. As the opening will going to take place, flow of blood inside the pulmonary artery and the aorta, and after that again the relaxation of ventricle will going to start. Then the due to the relaxation, closure of the semilunar valves and the opening of AV valves. Okay, both work in the opposite way. Okay, that will going to open again. So rapid inflow stage will going to come. After the rapid inflow stage, there is the joint diastole, means the all four chambers are in the relaxed stage and ventricles are continue filling by the by the blood which is coming in the atria through the vena cava and the coronary sinus. Okay, then the atrial systole will going to take place. So the blood from the muscles of the walls of the heart will walls of the atria will going to reach to the ventricles. Then the atria come in the diastole. Then again the ventricular systole will going to come. So this is the cardiac cycle which is going throughout the complete, we can say, in the heartbeat. Okay, in the one heartbeat this cardiac cycle is present there. We have studied this cardiac cycle so long, but that is just of milliseconds. Okay, as we know, in the 60 seconds there is the 72 times heartbeat will can be seen. Okay, or can be heard. So this is all about the cardiac cycle. Anyone have any doubt? Sinchana, Anvit,
No, sir.
Anvit?
No, sir.
Okay, Nitish?
No, sir.
Okay, Nitish, from the next time please join the class on time, because I think so we have come between the class. Okay, so now still we have half an hour, up to 6:30 only I will take, because I know you are studying from the 2 o'clock. Okay, so last thing, important thing we are going to discuss about are the volumes of blood related to the cardiac cycle. Volumes of blood related to cardiac cycle. Okay, so the first volume we are going to talk about is called as the end diastolic volume. And diastolic volume. So what this end diastolic volume means? During diastole, filling of ventricles normally increases the volume of each ventricle to about 120 ml. Okay, this is all about the end diastolic volume. Means if we can say during the diastole stage, when heart is in the diastole or the relaxed stage, blood is filling continuously into the ventricles. Okay, so the volume which is present after the diastole, complete relaxed stage, means if I say that relaxation stage of the heart ends, start from the 0.1 second and end on the 0.4 second. So the volume of blood which is present after the 0.4 second or at just 0.4 second, because after it the systole will going to take place, relaxation will going to end. So at the end of the relaxation there is the around 120 ml of the volume of the blood is present. Okay, so that is called as the end diastolic volume. Then comes the another volume that is called as the stroke volume. Stroke volume. Okay, so what is stroke volume? As the ventricles empty during systole, volume of ventricles decreases by 70 ml. Going to decrease by the 70 ml. Okay, so what we are saying, we are defining the stroke volume, and while defining the stroke volume we are saying that during the systole or the contraction of ventricles, we know during the contraction of ventricles blood is pumped in the pulmonary artery and the aorta, and during this contraction the blood which is pumped in the pulmonary artery and aorta is around the 70 ml, because the whole blood which is present in the ventricles, from that whole blood around the 70 ml of the volume is decreased. So according to that we are saying that 70 ml of the blood is pumped in the pulmonary artery and the aorta. Okay, so that is called as the stroke volume, or in the another word we can also say stroke volume is the volume of blood pumped by pumped by each ventricles in aorta or pulmonary artery in each beat. Okay, in each beat, because we have already discussed about it that heartbeat is equal to the ventricular beat or the apex beat, means the ventricular contraction is the prominent contraction. So heartbeat is equal to the ventricular contraction. So that is why we are saying that the volume which is pumped into the aorta and the pulmonary artery in the each beat is around the 70 ml, and that is called as the stroke volume. Okay, so this is the second volume. Now third volume we're going to talk about is called as the end systolic. We have already talked about the end diastolic. Now we are going to talk about the end systolic volume, is the volume which is left after the systole. End systolic volume. So what is end systolic volume? This is the remaining volume in each ventricle, remaining volume in each ventricle after systole, means after the contraction of the ventricles, the blood which is left in the ventricle after the systole. And when we will going to calculate it, that how much blood is left inside, so what you're going to do, end diastolic volume, okay, that is present at the end of the diastole, means diastole is ending, means now ventricles are fully filled, so that is called as the end diastolic volume. And we have already studied about the stroke volume, that the blood which is pumped into the pulmonary artery and aorta. So when we will going to subtract the stroke volume from the end diastolic volume, we will going to get the end systolic volume, that is the ESV. So end diastolic volume is around 120 ml, and the stroke volume is around the 70 ml. We have already discussed. So end systolic volume comes around the 50 ml. Any doubt, Sinchana, Anvit, Nitesh?
No,
No, sir.
sir.
Okay, fine. Now one more thing we will going to discuss about, that is called as the ejection fraction. So what is the ejection fraction? The fraction of end diastolic volume fraction of end diastolic volume which is ejected out. Which is ejected out. Means we are asking for the ejection fraction. So ejection fraction is around, it is the stroke volume upon the end diastolic volume. Why? Because ejection fraction is the fraction of end diastolic volume which is ejected out. So ejected out is the stroke volume. So stroke volume about the and the end diastolic volume. So you can calculate it. Stroke volume is around the 70 and end diastolic volume is around the 120. Okay, so you can calculate, but it is not important. The value is not important. You just have to know that what is the ejection fraction. Okay. Now, so ultimately we reach to a conclusion and we have to talk about the cardiac output. Means after this complete study of the cycle, all the stages which are going inside the heart, we have to talk about the cardiac output. Means what is coming from these events. Cardiac out means the cardiac cycle. Okay, so cardiac output is what? Amount of blood pumped out by ventricles per minute. Okay, you have to be very bound with the unit time. Okay, so in the per minute, the amount of blood which is pumped out from the ventricle is called as the cardiac output. So if we talk about the normal value, so normal value is around the 5 liter per minute. Okay, 5 liter per minute is the normal volume of the cardiac output. And how will we will going to calculate the cardiac output? How we are saying that it is the 5 liter? We are saying just because we know that in the each heartbeat we have the heart rate of the 72 per minute. Okay, and we know in the each heartbeat there is the flow of 70 ml of blood. That is what we are calling the stroke volume. So heart rate into the stroke volume, that is 72 multiplied by the 70. So that is coming around, or we can say approximately equal to the 5 liter per minute. Okay, so this is we are calling the cardiac output. So this much is for today. In the next class, we will going to study about the different heart sounds. Okay. Then most of the important part of the heart is completed. After that, we'll going to discuss about some of the disorders which are related to the heart. Okay. So this much is for today. Anyone have any doubt? Sinchana, Anved, Nitish.
No, sir.
Okay, fine. So we are leaving. Thank you so much.